Hi, this is Jeline from the Honors Tutorial. Our topic for today is about loss of exponents for division. This is under Mathematics 7. Let us have our first rule for the loss of exponents for division. We have here the quantity of a over b raised to n is equal to a raised to n over b raised to n. Let us have our first example and then let's apply the rule that we have here. So let's say that we have here m, the quantity of m over n raised to 7. So following the rule here, we just need to distribute 7 to each of the term here in the parentheses. So just copy m, the variable, and just write 7 here as the exponent, and then copy n, the variable, in the denominator, and then copy 7 as the exponent for the denominator. Why is it 7? Because we have here 1 as the exponent of m and n. Also, remember when the exponent is outside the parentheses, you need to multiply the exponents which is inside and outside of the parentheses. So 7 times 1 is 7, so that we have 7 in our numerator, and then 7 times 1 in our denominator, that is equal to 7. So that's why the answer here is m raised to 7 over n raised to 7. If you are thinking of dividing it, you cannot divide it. It is because we don't have the same variable, so it is not possible. What do I mean by the same variable? You should have the same letter for you to simplify the variables. But in this case, we don't have the same letter, but instead we have m and n. Though they have the same exponent, but still, you cannot simplify it. Let's have number 2. The other example here is the quantity of CD over EF squared. So same process, though we have here additional variables unlike the first example. So same process, please distribute the exponent which is outside the parentheses to all of the terms that we have here inside our parentheses. So same concept also. We have here 1 as the exponent of C, D, E, and F. But we cannot see it because if the exponent of a variable is 1, we usually don't write it. It is invisible. So now we have to distribute 2. 2 times 1 for C, that is 2. So we have here C squared. 2 times 1 for D is 2 also. So we have here D squared. And then we are done with the numerator. Let's have the denominator. 2 times 1 for E is 2. So we have here E squared. And 2 times 1 for F is 2 also. So that we have here F squared. Actually, we cannot divide it also. It is because of the same reason for number 1. We don't have the same variables here because we have here C, D, E, and F. So this is the answer already. Next, let us have our next example. So that is number 3. So we have here this example. Let me write it. So this is the given for number 3. That is the quantity of 5GH over 7JK cubed, or raised to 3. So therefore, we are going to simplify it. Of course, following the same rule that we have here. So you have to distribute 3, the exponent, to each of the following terms in the parentheses. So therefore, it will become 5 cubed or 5 raised to 3, g raised to 3 or g cubed, h raised to 3 over 7 cubed, j cubed, k cubed. And then we have to simplify what is 5 cubed, and that is 125. So we have here 125 g cubed, h cubed, and then here below, we have here 7 cubed, that is 343 j cubed, k cubed. So this is the final answer for example number 3. Next, let us have example number 4. For example number 4, we have here the quantity of 2a cubed b squared c over 4a b raised to 7 c squared raised to 5. Same process, we have to distribute 5 to each of the term inside the parentheses. So that is 2 raised to 5, a raised to 3 times 5, b raised to 2 times 5, and c raised to 5. Why is it c raised to 5 only? This because the exponent of c is 1, so 1 times 5 is 5. Next, let's have the denominator now. So we have here 4 raised to 5, and then we have here a raised to 5, b raised to 7 times 5, and also we have here c raised to 2 times 5. And then let's simplify. Let's simplify it here. So 2 raised to 5, that is equal to 32. Why is it equal to 32? Because 2 raised to 5 means 2 times 2 times 2 times 2 times 2. So meaning you have to multiply to the base to itself 5 times because the exponent is 5. So 2 times 2 is 4, times 2 that's 8, times 2 that's 16, times 2 it's 32. So therefore the answer is 32 when it comes to 2 raised to 5. And then let's have a in the numerator. So a raised to 3 times 5, that's 15. So a raised to 15. And then b raised to 2 times 5, that's 10. And then we have here c raised to 5. Now we have here the denominator. So 4 raised to 5. So always remember that 4 raised to 5 doesn't mean 4 times 5. No, it's not. It means 4 times 4 times 4 times 4 times 4. It means that you have to multiply 4 5 times to itself. So 4 raised to 5 is equal to 1024. So we have here 1024 as our denominator. And then of course, let's have our variable. So that is a raised to 5, b raised to 7 times 5, that's 35 here. And then c raised to 2 times 5, that's 10. And then we can still simplify this because there's still a number that can divide your numerator and denominator at the same time without remainder. If you want to use 2, then it's fine. If you want to use 4, it's fine also. And if you want to use 32, it is fine. As long as you will get the correct answer at the end. So if you have 32 divided by 32, that's 1. 1024 divided by 32, that's 32. And then, as you can see, we have here the variables. A has a partner in the denominator, so we can simplify it. So this is the technique. Just subtract 15 and 5, and then the difference will be put on the side or on the place of the exponent which is bigger than the other exponent. So for example, 15 minus 5, that's 10. Where will I put a raised to 10? On top or in the numerator, because 15 is greater than 5. Next, how about 10 minus 35? I will subtract these numbers and then I will choose on which side I will put the difference, just like this. 10 minus 35, that's 25. Where will I put b raised to 25? In the denominator, because 35 is bigger than 10. Next, c raised to 5, c raised to 10. I can simplify this. How? By subtracting the exponents. So 5 minus 10 is c raised to 5. Where will I put c raised to 5? In the denominator also, because c raised to 10 is bigger than c raised to 5. And then, is this the final answer? Not yet, but it is close to that. It is because we can write 1a raised to 10 as a raised to 10 only, because 1 is an invisible number when it is used as a numerical coefficient for a variable. And then over 32b raised to 25, c raised to 5. So this is the final answer for number 4. So that's it for loss of exponent for division. I hope that you have learned something today about it. Um, there is more rules in division that we have to study, but let's cut this topic here and kindly watch the part 2 of this in our page and in our YouTube channel. So if you have inquiries about this topic or about us, please contact our page, The Honors Tutorial. Thank you and God bless.